Okay, so this topic is called setting up a reaction table, as you can see. And I'm going to screenshot it and put it over in my whiteboard. And I'm going to ask you to pause the video, read it, and guess what's going on. Okay, so supposing that you did pause it and guess what's going on, you had to read it, of course, and that's going to take a bit. It looks like we've got a 500 ml flask and a certain amount of nitrogen and a certain amount of nitric oxide. And it looks like there's no oxygen that's given here. Okay, no problem, we can do that. So my initial concentration of this is going to be, if concentrations are in moles per liter, my initial concentration of nitrogen is going to be what? Consider pausing the video now. What is my initial concentration of nitrogen? Okay, it's going to be 0.40 moles per 500 milliliters, which is 0.5 liters, right? Which is 0.8. If you divide that, we can't, on the MCAT, we can't do that, right? So we can say 0.4 over, and that's 0.5, so it's like 1/2, which is the same thing as 0.4 times 2 over 1, which is 0.8. Okay? So it's 0.8. So this is going to be 0.8. That's how much I start out with. Now, pause it and tell me how much, look and see how much nitric oxide is there. Okay, so nitric oxide, I hope you paused it, in moles per liter is going to be 0.9, right? Is that how much that was there? 0.9 moles, right? 0.90 moles divided by a half a liter, 500 mils, which is going to be what? Pause the video and tell me how much that is. Okay, it's 1.8 mole. I hope you're pausing it. I'm acting like you're pausing it. Okay, that's the initial amounts of those two. Now, look again. Pause the video and look at this question stem and see how much oxygen am I starting out with. Okay, 1.8 nitric oxide, and it was starting out with 0 oxygen, right? Because there's no mention of it, right? We're taking this flask and we're putting these two things in it, and by omission, we're saying, well, must not be putting any oxygen in it, okay? So since there's no oxygen going into it, and this is the reaction here, it's going this way, right? We must be adding some because you can't take away from 0. So here's the thing that I want to practice for this one. If you're adding X to this, what's the change in N2? Make a guess. Pause the video, make a guess, and then compare your answer to mine. Okay? So if we're adding X, it must be coming this way. We must be adding X to this as well, right? Because this was 1-to-1. You see that? Okay, now pause the video and see what's the change in nitric oxide. Okay, the change in nitric oxide, since we're going this way, right, and we're going that way because we started with 0. We started with 0, had to be going that way. So we're going that way. The change in nitric oxide is minus 2x. Can you see my writing here? A little ugly with the boxes behind it. Okay, last question. What's the equilibrium amount of this stuff? Pause the video and tell me what's the equilibrium amount of nitrogen. Okay, and the answer is it's 0.8 plus x. Okay, now pause the video and tell me what's the, make a guess. You've got to pause the video, make a guess. What's the amount of oxygen at equilibrium? Okay, hopefully you paused it. It is X, 0 plus X, which is just X. And last question, and this is it. That's all we're doing here for this video. What's the amount of nitric oxide at equilibrium? Okay, it is 1.8 minus 2x. Okay, we're not going to set the equilibrium constant up. If we did, it would look something like this: products over reactants, right? And you'd have to decide what's the products and what's the reactants and what are the exponents. But I'm not going to do it with you right now. All we want to do is just setting up the reaction table, and then we'll practice this more later. Hope that's helpful. Good luck to you.